Hi everyone, it's Mrs. V here, and today we are going to extend our knowledge of back titration calculations by doing a more complicated example of a back titration. So let's get that whiteboard on and let's challenge. In our last back titration video, we did a standard example where we calculated the percentage of calcium carbonate in some limestone. Now, that was a fairly standard example. We're going to use the same steps today, but we're going to up the ante a little. We're going to have a more complicated example, but we're still going to follow those same steps. This will always work for you. So let's have a look at this example. We're analysing the ammonia content of a brand of cloudy ammonia. Cloudy ammonia is just a cleaning solution. You find it in the supermarket. And a student weighed out 10.213 grams of the cloudy ammonia, and he immediately made it up to 250 ml in a volumetric flask. Then he took a 20 ml aliquot. Remember, aliquot is just the sample that you take from a total solution. And he immediately reacted that with 20 mils of 0.105 mole per litre hydrochloric acid. So this is our total acid. So let's mark that in our question. So we have our 20 mils of 0.105 mole per litre hydrochloric acid. So that is our total acid. Then, after that reaction was complete, it took 6.45 mils of 0.0500 moles per litre sodium hydroxide solution to neutralise that. We can tell, it says after this reaction was complete, that immediately says that we're now looking at our titration data. Finally, we need to work out what it is that we need to find. We are to calculate the percentage of ammonia. It's very important to remember what it is that you have to calculate. So let's proceed. First of all, let's calculate our total acid. So our total acid data, we marked it in the question. We're going to calculate the moles, and this is hydrochloric acid. And that is equal to concentration times volume. Our concentration here was 0.105. And our volume was 20 mils, which is 0.02000 litres. And if we run that through the calculator, we get 2.10 times by 10 to the minus 3 moles. All right, step one is complete. We now know how many moles of acid in total was added to the cloudy ammonia. Our next step is to work with the titration data. So in the titration, our reaction is between sodium hydroxide and hydrochloric acid. So let's write ourselves an equation first. Sodium hydroxide and hydrochloric acid. Acid plus metal hydroxide gives us metal salt, so this will be sodium chloride, and water. Water being a liquid. All right, so what do we have in our titration data? We have information about the sodium hydroxide. So we can calculate the moles of sodium hydroxide. Again, through concentration times volume, we find our concentration this time of the sodium hydroxide was 0.0500 moles per litre, and our volume was 6.45 mils. So that's 0.00645 litres. And again, we can run that through the calculator, and we get 3.23 times by 10 to the minus 4 moles. Now we can use stoichiometry from the titration reaction to calculate the moles of hydrochloric acid. So the moles of hydrochloric acid over the moles of sodium hydroxide is 1 to 1. And of course, that means our moles of hydrochloric acid are equal to our moles of sodium hydroxide. And we just calculated that to be 3.23 times by 10 to the minus 4 moles. All right, on to our next step, which is, of course, to work out how much of that total acid was left over. And of course, we do this by subtracting the leftover acid from the total acid. So let's have a look. So we want the amount rather that reacted with the cloudy ammonia. And that's the total acid. And we're going to subtract the leftover acid. So our total acid was 2.10 times 10 to the minus 3. And we're going to subtract our leftover acid, which was 3.23 times by 10 to the minus 4. And that's going to produce an answer of 1.78 times by 10 to the minus 3 moles. All right, moving on with our final step now. Now we're actually going to do our calculations that lead us to that percentage of ammonia. So for the percentage of ammonia, we'll need the mass of ammonia. For the mass of ammonia, we're going to need the moles of ammonia. So let's work from what we have. We have our moles here. We just calculated, this is the number of moles of hydrochloric acid. So this is the moles of hydrochloric acid that reacted with the ammonia. So we have a start point to do some stoichiometry. Of course, for stoichiometry, we're going to need a balanced equation. Now, this is a balanced equation that students tend to find really quite difficult for some reason. I think we're not used to seeing ammonia as a base. So ammonia solution is going to be reacting with hydrochloric acid solution. And I think we want acid plus base gives salt plus water, but in this case, it does, but where our salt is going to be ammonium chloride, and it's just going to be an aqueous solution. So even though that's quite a simple equation, I've found students have a lot of trouble writing that one. So it's good that we've seen it in an example. All right, we know our moles of hydrochloric acid, but we need to know our moles of ammonia. So doing our mole ratio, our mole ratio is 1 to 1, and therefore our moles of ammonia is equal to our moles of hydrochloric acid, which is equal to 1.78 times by 10 to the minus 3 moles. All right, this is the tricky part. That is the amount of ammonia in the 20 ml sample that was taken out of the total. So we're going to be really careful to remember that. So this is the amount of ammonia in the 20 ml sample, not in the 250 mils. So that is really important. So what we're going to need to do is if you took 20 mils out of 250, then you're going to need to multiply your answer by 250 over 20 to get the total ammonia. All right, let's proceed with this. So our total ammonia is going to be equal to our 1.78 times 10 to the minus 3 moles times by 250 over 20, which is 12.5. And that's going to give us 2.22 times 10 to the minus 2 moles. All right, but that's not the end, is it? You might be tempted to think we're all done now. we have our moles of ammonia, but we were asked for the percentage of ammonia. So for that, we're going to need to go on and convert this to a mass. So our mass of ammonia is going to be equal to our moles times by our molar mass. Our moles is 2.22 times 10 to the minus 2. And our molar mass is 14.01 for the nitrogen and 3 into 1.01 for the hydrogens. And that's going to give us 0.379 grams. Now, we might be tempted to think we're done. We've got the mass of ammonia, but we weren't asked for that. We were asked for the percentage. So let's go on and calculate the percentage. So the percentage is the mass of ammonia over the mass of the sample. And if we look back, the mass of the sample was 10.231 grams. And then we multiply by 100 to get that to a percentage. And that comes out to 3.70%. All right, we've done it. We've got right to the end of a really tricky example. Really well done, guys. Well, how did you go with that one? That was tough. But if you made it to the end of that calculation and you understood what was going on, really well done. There is going to be nothing hard about back titration that they can trick you with. If you found this video really useful, if you found that it helped you get through some of your back titration calculations, then please consider giving the video a like. And as always, if you would like to find out more about this fabulous subject we call chemistry, then subscribe to my channel and watch some more videos. I am going to see you guys in the next video.